physics project
done by Jericho and Shuang of class 3G. Throughout this instructional video, we will be finding the densities of three objects each using different methods. Object A is a regular object, Object B an irregular object, and Object C a differently shaped object from Object A. What you will need throughout the experiment: an eureka can, a measuring cylinder, an electronic scale,
a vernier caliper,
a micrometer screw gauge, and a meter ruler. Object A is a 30 cm ruler. The method is using tools to find its various dimensions, then using formulas to find its density. Firstly, we find its mass. After using an electronic scale, we find its mass to be 23.3 grams.
Next, we will find its thickness.
We will use the micrometer screw gauge for this part.
After both ends meet, 3 turns on the ratchet ensures that it is secure.
The ruler may not be uniform throughout, thus taking measurements in two places, then finding the average will make sure it is accurate.
Both measurements are 2.29 mm each.
Hence, the height is the average of both values, which is 2.29 mm. Next, we will find the length of the 30 cm ruler. Using a meter rule to find its length, we find its length to be 31.3 cm. Next, we will find its breadth. We will use the vernier caliper for this step. The base of the ruler is found to be 3.11 cm. Next, we will take another measurement on another part of the ruler. This part is measured to be 3.10 cm. The breadth of the 30 cm ruler is the average of both values, which is estimated to be 3.11 cm. Hence, we will use the formula breadth times length times height to find the volume of the 30 cm ruler. Hence, the volume is 3.11 times 31.3 times 0.029, which equals to 22.3 cm3. We will find the density using the formula mass over volume. 23.3 over 22.3 equals to 1.04 grams per cm3. We have found the density of Object A. Now for Object B. Object B is a stone. The method is using a eureka can to find its volume, then using other formulas to find its density. Using an electronic scale, we find its mass to be 19.8 grams. Next, we find the stone's volume. We will use a eureka can to find the stone's volume. After placing the stone into the can, we will wait for the excess water to drip out into the measuring cylinder. Therefore, the density of the stone using the mass over volume method is 19.8 divided by 6, which equals to 3.3 grams per cm3. We have found the density of Object B. Now for our last object, Object C. Object C is a Singapore 50-cent coin. The method is using a measuring cylinder to find its volume, then using formulas to find its density. We will first find its mass. Using an electronic scale, we find its mass to be 6.6 grams. After that, we find its volume. We will use the measuring cylinder to measure the coin's volume. After the drop, the increase of volume is the volume of the coin. Its volume is 1 cm3. Hence, its density according to the mass over volume formula is 6.6 divided by 1, which equals to 6.6 grams per cm3. We have found the density of Object C. Thank you for listening to us throughout the video.
And do not forget to have fun with physics.
On top of the world, I'm on top of the world.